Okay, Assalamualaikum warahmatullah. Okay, good day everyone. So today we're going to cover about carbon compound. Okay, it's actually the starting point for you to learn about organic chemistry. Okay, of course, in your textbook, some textbook says the topic is about carbon compound. Some textbook say the topic about organic chemistry. Let's look together what is actually the connection between carbon compound and also organic chemistry. We're going to learn today. Okay, we're going to cover two basic introduction about for the topic. And the first part of the lesson, we're going to explore about carbon compound and organic chemistry or organic compound. So what does these two terms means, and then how they are relate to one another. And the second part, I'm going to introduce about homologous series, okay, the characteristics and also the summary, basic summary about the homologous series, okay. And I hope that at the end of this lesson, you should be able to actually differentiate between organic and inorganic compound, explain the few terms including hydrocarbon. Okay, you should be able to actually state what it means, and also describe more in detail about the characteristic of homologous series. Okay, what does each homologous series has for each member in the group. Okay, so basically these are three criteria that I hope you're going to achieve at the end of this lesson. All right, so before we start, so I believe you may have come across the word, the term organic previously. Okay, I just want to give you a few minutes. Can you recall where that you actually get or where they actually see the word organic? Okay, can you think? Any idea? All right. So I believe some of you might come across the word organic when they buy food or they buy some product. Okay, it may say that this product is 100% organic, and then if you search, okay, if you search from the internet, you will find that usually when it comes to product or food that says that made in the organic way. So they usually associated that the organic with not using the chemicals. Okay, basically the product is produced naturally by using natural ingredients. Okay, without using any chemicals. But when we see organic chemistry, it just like doesn't match, because how can something not using chemical become organic chemistry itself? So we are using the word organic in different contexts over here. So we're going to see after this what does actually organic chemistry mean. But in some way they are related to one another. So what is actually organic chemistry? And of course, another term that I'm going to introduce today, what is actually the connection between organic chemistry and also carbon compound? Okay, basically organic chemistry and carbon compound, they are closely related, because organic compound basically they are actually a carbon compound, but carbon compound not necessarily is actually organic compound. Okay, so carbon compound basically compound, of course, from the name itself, is actually compound that contain carbon. So any compound that contain carbon can be considered as a carbon compound. And the carbon compound we can divide into two groups. okay, based on the source, okay, to make it easier. Okay, if the compound derived from living things, we can call it organic. This is, I think, where the word organic in the product come from. And then if the carbon compound derived from non-living things, okay, so it's considered as inorganic. Okay, so if the compound contain metallic carbides, okay, or if the compound contain cyanide, okay, or if the compound actually oxide of carbon, for example, carbon dioxide, carbon monoxide, so it's considered inorganic. And also, any compound also is considered as inorganic if they do not contain carbon at all. Of course, we are talking about carbon compound, but if you see the compound does not contain carbon, so basically it's actually inorganic. So this what we call it as very simple connection with organic or inorganic, okay, based on carbon, okay, based on the presence of carbon in the compound. Okay, so we're going to actually explore more in detail about organic, so we're not going to touch too much about inorganic. Okay, so you know that organic is actually derived from living things. Of course, how do we know that any particular compound derived from living things? Because you haven't come across many compound in your study. Okay, there's a few ways. Okay, so organic compound can also be divided into two groups. Okay, this is actually the easiest way for you to know if the compound is organic or not. Okay, and the first one is hydrocarbon. Okay, so one group in the organic compound. So hydrocarbon is actually compound that contain hydrogen and carbon only. Okay, they do not have any other element in the compound other than carbon and hydrogen. So the example of the compound is alkane. Alkane is actually one of the alkenes and alkynes, three homologous series that we're going to learn later. And also, organic compound can also be divided into non-hydrocarbon. Okay, so this is the second group for organic compound. So non-hydrocarbon, it doesn't mean that it doesn't contain carbon and hydrogen, but in fact it contains carbon, hydrogen, and other atoms. And other atoms such as oxygen, chlorine, maybe sulfur. Okay, C is considered non-hydrocarbon. So at the bottom here, you can see is actually hydrocarbon. And on the right is actually non-hydrocarbon. Okay, so using this is going to be easier for you to identify is organic or not. Okay, using carbon and using hydrogen. Okay, so you know straight away that is actually organic compound. Okay, and then hydrocarbon can also be further divided into two categories. The first one is we call it saturated hydrocarbon. So saturated hydrocarbon means that if the compound only so basically the classification into saturated or unsaturated is based on how carbon atom are bonded. Okay, if they are bonded with single covalent bond, only single covalent bond in the compound, so it's considered as saturated. Okay, saturated hydrocarbon. However, if there is actually at least one carbon-carbon double bond or one carbon-carbon triple bond present in the compound, so the compound is considered as an unsaturated hydrocarbon. So this is actually applies for the hydrocarbon. Okay, for the hydrocarbon, if they have a multiple bond, at least one. Okay, why is this at least one? Because you can have more than one. Okay, in the compound, right? So basically, this is actually the subcategory under hydrocarbon. So you can see that. Okay, you can see that if you want to summarize that what we covered so far. So carbon compound can be divided into two groups. So organic and inorganic. Okay, and the organic compound or organic, which is what we're going to cover, organic chemistry. Okay, so organic compound can be divided into two, which is hydrocarbon and non-hydrocarbon. So this is actually the easiest way for you to identify if any particular compound is organic or not. Okay, based on this. Okay, contain carbon and hydrogen only, which is hydrocarbon, and then may contain carbon, hydrogen, and other elements, so it's considered as non-hydrocarbon. Hydrocarbon can further be divided into saturated and unsaturated. Okay, so saturated refers to carbon-carbon is bonded with single covalent bond. So only carbon-carbon single bond present in the compound. If at least one multiple bond, either carbon-carbon double bond or carbon-carbon triple bond present in the compound, then the compound is considered unsaturated. The compound considered unsaturated. Okay, so basically this is a brief overview, okay, about how to classify the compound into organic or inorganic. Okay, because you can see on the inorganic side, I didn't touch so much because this is not what we're going to cover. Okay, so we focus more on organic part. So I hope now you have a clear understanding about organic and inorganic. I hope you should be able to actually identify if you're given any particular compound, the compound is organic or inorganic. Okay, based on the source. All right. Okay. Of course, let's test yourself if you understand the topic well. Okay. So I've prepared two questions. Question number one, I just want to ask you to classify which one. Classify the compound. So either the compound is organic or inorganic. And the second one, classify the compound into hydrocarbon or non-hydrocarbon. Okay, so you can pause the video later to answer the question. Okay, or if you need to see some notes, you can actually play back the video. Okay, just to make it easier for you. Okay, so you're supposed to spend about 2 to 3 minutes to answer this question. I think 2 minutes should be okay to answer this question. Okay, so 2 minutes from now, please start to answer the question. All right, I hope you already answered the question. So let's go through the answer together. All right, the first one, methanol. So methanol is organic. How do I know a methanol is organic compound? If you still remember, one of the classification is the presence of carbon. Of course, this is a carbon compound. And then this methanol falls under non-hydrocarbon category. Okay, because it contains carbon, hydrogen, and also oxygen. Okay, so other element than carbon and hydrogen. So basically, methanol is organic. Ammonia is inorganic. If you see from the formula, ammonia does not contain any carbon at all. Carbon dioxide is also inorganic. If you see from the previous slide, oxide of carbon is actually an inorganic compound. And the last one, butane, is organic. If you see from the formula, it only contains carbon and hydrogen. So this is actually hydrocarbon. Okay, so it's organic. So it's quite easy. And the last one, classify the following into hydrocarbon and non-hydrocarbon. Okay, you have 4. Okay, so hydrocarbon, only contain carbon and hydrogen, which is C2H2 and C5H12. Non-hydrocarbon because it contain carbon and hydrogen and other atoms. And here we have CH3COOH, which is we have represent of oxygen, and the second one also represent of oxygen, CH3COOCH3. Okay, so this is actually non-hydrocarbon. So it's quite easy for you, right? So we finished the first part for what we're going to cover today. So now we're going to move into the second part about the homologous series. Okay, I'm not sure if you have come across the term homologous series before. So homologous series can also be you can also think as a family. Okay, homologous series actually refers to family. So if we say that this particular compound belong to this homologous series, so it means that this particular compound belong to that family. So basically homologous series talking about the group, group of compound. So homologous series refers to a group of compound that share similar characteristic. Okay, so basically if we want to classify the compound into what we call it, into any particular homologous series, so we need to see what kind of characteristic that compound has, and then we try to match which the one that we have in our homologous series. Okay, I listed down here over here 5 characteristics. Actually, there are more characteristics for the homologous series, but this one is quite important one. Okay, the first one, each member of the homologous series must have same general formula. Okay, and then they should have similar chemical reaction or similar chemical properties. They must have same functional group. Okay, and the fourth one, they should be prepared through similar method of preparation, and usually each member differs by CH2 group. So that means that one member to another member, there will be the addition of CH2 group in the compound. Okay, so I know some of this might sound slightly confusing for you, but hopefully as we go along through this lesson, you will understand better about homologous series. Okay, you must actually remember this characteristic very well for you to answer any question regarding homologous series. Otherwise, it's quite difficult for you to actually answer the question. So I usually I usually ask students to remember about SASI. So it's going to be easy. What is SASI? So same, similar, same, similar. But don't exchange, okay, the word same and similar, because there are reason why I use SASI rather than I put all the same or same, because not everything, not actually each characteristic is the same. Okay, some they are similar. Of course, they can actually have slight different what we call it properties. Okay, so please please abide with this characteristic or this way of saying the characteristic. Okay, so now having you have or knowing this characteristic, let's go through together one by one to make you understand more about this characteristic. So you have two compound over here. Okay, let's say this one compound A, this one is compound B. Okay, so if you see from this compound, you can, because you are given the structure, this is called a structural formula. So if you see from this structural formula, you will find that, okay, these both compound has same functional group. Of course, we haven't learned about the functional group yet, but just looking at the structure, you know they have something similar. Okay, they have something similar, which is C carbon double bond. Okay, this is actually the functional group. So basically, what does the functional group means? Functional group basically means that that particular atom or particular group of atom will take part during the reaction. Okay, so basically, if this compound undergo a chemical reaction, only this part will take part. The rest of the atom in the compound will remain unchanged. Okay, remain unchanged. And also, if you see the difference between compound A and compound B, okay, you see that the other difference is this part. Okay, this is what I mentioned earlier about CH2. Okay, the difference between A and B is just that B contain one more CH2 group. Okay, so this group, so this is actually the homologous series. This is actually alkene, one of the homologous series. Okay, one of the homologous series. So we identify the homologous series based on the functional group. Okay, functional group. Let's look at the second one. Okay, second one, slightly similar. A and B is the same structure that we see previously, while for structure C slightly different. Okay, if you see from the structure, you can know straight away that C is different from A and B because C does not contain functional group as A and B. Okay, so it's quite straightforward if you are using the structural formula or if you are given the structural formula. However, if you are not given the structural formula but you are given the molecular formula, so there will be a different story because you don't actually know how the atom are bonded. Okay, you only have the molecular formula. Okay, so if you are given the molecular formula, you can actually identify the homologous series based on the general formula. Okay, general formula used in the general formula that make up the compound. So let's look compound A and B. So compound A and B, they are following or matching the general formula of CnH2n. So CnH2n is actually general formula for alkene. So if you see from the formula, if n equal to 3 here, here is supposed to be 6, which is true for this one. If n equal to 4, here is going to be 8. It's also correct for A and B. However, if you see for C, if you put CnH2n over here, if C equal to 3, here is supposed to be 6, but here is 8. So it does not follow CnH2n. In fact, it follows CnH2n plus 2. Okay, so this one is another general formula, belongs to another homologous series, which is in this case is belong to alkane. Okay, so C belong to alkane. Why? How do we know? Based on general formula. If you provided that you don't have the structural formula, of course. If you have the structural formula, it's going to be easier for you to identify. Okay, so I'm going to for this slide, I just want to show you about the general formula. Okay, of course you need to memorize the general formula. You're going to learn about general formula in our next lesson when we go through one by one for each homologous series that we have. The third one is about method of preparation. So if you know one member of any particular homologous series can be prepared in one way, that also means that all members or the other members in same homologous series can also be prepared in similar way. Okay, what does it mean? It sounds like it's slightly confusing, right? But here, if you see from the slide, I hope that it shows you more. It shows you or it can clarify, okay, about that facts. Okay, for example, here we have propanol. Okay, propanol can be prepared from propene. Okay, propanol is belongs to alcohol, one of the homologous series, and then propene is belongs to alkene, which is another homologous series. So basically, we can actually prepare alcohol by reacting alkene with water through hydration reaction. Okay, in this case, we have here is actually propene. We add with a steam over here, and then we get propanol. Okay, so you can see that the name of organic compound usually depend on the number of carbon it contains. That's why you say carbon compound is quite crucial part of the organic chemistry. Okay, if a compound contain 3 carbon, we start with 1. If the carbon compound contain 1 carbon, okay, for the hydrocarbon obviously, so the name will start with meth, M-E-T-H. If it contain 2 carbon, it start with eth, E-T-H. 3 carbon prop, 4 carbon but, 5 carbon pent, and 6 carbon hex, and so on. Okay, we're going to cover about that later on when we do the naming of the compound. Okay, so because we know that propanol can be prepared from alkene, obviously it also means that butanol can also be prepared from alkene as well, because butanol is also a member of alcohol. Okay, a member of alcohol. So butanol can be prepared from butene, and pentanol can be prepared from pentene. This is what I mean by it can be prepared through similar method of preparation. Okay, because they belongs to the same homologous series, the preparation should be the same as well, right? We're going to see about the chemical properties. So if we learn about one particular member of the group, we don't have to learn about all, because obviously the other member of the homologous series will also react in the similar fashion. For example, over here, if I'm giving you a direction between butene and bromine, okay, when butene react with bromine, it will decolorize the brown color of bromine water. So if I ask you what happened when we react hexene with bromine, which is hexene also one member of alkene, obviously you know that butene will decolorize bromine water. Hexene, which is also alkene, definitely it will decolorize bromine water as well, because they belong to the same homologous series, so that they will have similar chemical properties. Okay, so as simple as that. So that's why when we learn about homologous series later, we're not going to cover all members. We're going to cover only few members, so that the rest of the members will follow the suit, how they react, how they are prepared. So basically, I already showed you 5 characteristics, including the addition of CH2 in the group. So I hope that by learning through this slide, you understand better about the characteristic of homologous series. Okay, it's basically the summary of the homologous series that we have. Okay, so we're going to learn about alkane, alkene, and alkyne. Okay, the first 3 is actually hydrocarbon. Okay, and then alcohol, carboxylic acid, and ester. So basically, this is the thing that you need to know. This is number 1. What homologous series and what general formula, what functional group, how the name ends. Okay, it's quite important. Example is fine, because as we go through the homologous series later on, you should be able to actually find more example. Okay, I just want to highlight over here about alkyne. I'm giving you about alkyne over here because alkyne is one of homologous series that we need to cover in SPM, but alkyne is not covered in in IGCSE. So I'm going to give you an early exposure about alkyne, so you have some idea about alkyne. Okay, it is good if you have this table in your notebook, or you can use the handout provided for you to actually if you have the information in the header or in the notebook, it's going to be easier for you to actually revise later on. Or if you start with a question, you just need to look back for this table, and then you can get the answer, because at the beginning it's going to be quite a lot of information for you need to memorize, but as we go along through exercise, then it's going to be easier. Okay, particularly about the general formula, because there are quite a lot of general formula for you to remember, because you need to memorize this. Okay, you need to memorize this, including the functional group and the structure as well. Okay, because if you don't actually memorize the general formula, it's going to be very difficult for you to identify which homologous series any particular compounds belongs to. Okay, by memorizing the general formula, is going to be easier, right? So basically, that's what we're going. That's what we need to cover today. Okay, I hope throughout the slide that we covered today, it gives you a clear idea about first about organic chemistry and also carbon compound, and the second one is about the homologous series. Okay, so this is actually a homologous series that we're going to cover, and the characteristic that you need to know as well. Okay, that's what I think I want to cover today. Before we end our session today, our lesson today, I just want to give you a simple question, just to actually have a short recap, or just to test yourself how much you understand about the lesson today. Okay, so you are given a compound over here, compound A, with the structural formula, and then I want you to identify the homologous series for the compound. And second one, what characteristics shared by the member in this homologous series. Okay, I think you're supposed to spend about 2 or 3 minutes. I think not 2 or 3. I think 3 to 4 minutes to answer this question. You can use the notes that you have, or you can actually use your handout to answer the question. Okay, so you can pause the video as previously. You can pause the video if you want to answer the question, and then I'm going to discuss the answer for this question after 2 or 3 minutes, or when you are ready with the answer. Okay, you can pause the video now and answer the question. All right, I hope you managed to answer the question. Okay, so let's look at the answer together and discuss about the answer. Okay, over here, state the homologous series for compound A. So the answer is alcohol. Okay, how do I get the answer? Okay, so basically you can get the answer using 2 methods. The first one by using the general formula, or by using the functional group. Okay, by using the functional group, right? So you can see over here we have functional group OH, or hydroxyl group, so it belongs to alcohol. Okay, because you are given the structure over here, but you are not given the molecular formula. But you can still, okay, see the general formula for alcohol, CnH2n plus 1 OH. So we have 2 carbon over here. Hydrogen we have 5. So if you see that it match up the general formula. Okay, it match up the general formula for alcohol. Okay, what characteristics shared by member is homologous series? I think that's the slide that I showed you just now, we have like 5 characteristics, so you can choose 2. Okay, you can choose any characteristic that you want, but I have 2 characteristics over here, have similar general formula and have similar functional group. Do you have the same answer like mine? If you have, that means that your answer is wrong, not correct. Why is wrong? Because we cannot use the word similar here. We must use the word same. So be careful. Okay. So when you're using general formula and functional group, you must use word same, not similar. Okay. So I hope by completing this short test, okay, it gives you a better understanding and clearer picture about homologous series. Okay, don't worry, because we're going to cover each homologous series in detail in our next lesson. So I hope that by following this lesson today, it excites you and give you more interest to study more about organic chemistry. Okay, thank you very much for your time for your lesson today. Okay, I hope that you should be able to answer the quiz that prepared for you after this. Okay, so thank you very much. Okay, see you in our next lesson.